Hello everyone! This is the first video I'm recording in 2025, so I hope it turns out well. This time I'd like to show how we can use a shader to create a digital clock, which we'll then control using a script. So let's get started. So, to simulate a digital clock, we construct the digits using vertical and horizontal lines. Just a brief reminder that I'm working in Godot engine version 4.3, but the code I create should be usable on any system that supports GLSL. So, as usual, we'll start by creating a new scene, where I'll add a color rect, set the usual dimensions, and add a new shader material. Let's right-click on scenes, create new scene. I'll call it, I don't know, digital. Okay, why not? Create, then right-click on digital and find color rect. Here it is. Create, and in the inspector, I'll set the layout transform chord size to 600 by 400. And the material must be a new shader material. Click new shader. Let's call it digital GD shader of a canvas item type and put it to the shaders folder. Okay, where is it? Here. Open, create, and click again to open it in the shader editor. Let's expand the window a little bit. And I'll delete everything we don't need, leaving only the fragment function. So vertex is gone, and so is the light. Great. Now I'll create the usual skeleton, where we shift the origin of the coordinates to the center and adjust the aspect ratio to prevent our clock from being stretched horizontally. It's a standard procedure I've used many times before. So let's create the uniform parameter. Uniform parameter vector 2 resolution with the default value vector 2 600 and 400. Okay. And in the fragment function, as I said, first I'll move the origin of the coordinates to the center, so we subtract 0.5 and fix the aspect ratio. U x is multiplied by resolution x divided by resolution y. Okay. I apologize for the typos I sometimes make while coding. The reason is that my usual laptop, which I typically use for recording tutorials, broke over Christmas, so now I'm working on a different one and I haven't fully adjusted to its keyboard layout yet. But I hope I'll get used to it quickly. Okay, so the first step is to generate a line with beveled edges so that the numbers have the proper digital shape. How do we do that? Let's start with a simple function that generates a slanted line with a double-sided gradient, which is why we use the abs function, absolute value, to mirror the results. I'll do it here. So float, call it line, with the parameter vector, here it is again. Sorry. Vec2 UV coordinates of the current pixel, and we will simply return, as I said, the absolute value, and the argument would be UVX plus UVY. All right. And before displaying this, it would be useful to define a uniform parameter for the color. Let's add it here. Uniform vector 3 RGB color. Let's call it simply color and give it a hint source color, so we'll have this nice color picker in the inspector. Initial value would be vector 3, 0.1, 0.1, and 1. to get a nice shade of blue. Okay, and now we'll extend the fragment function to take the result of the line function and multiply it by the set color. So here, float result is a line of the UV parameter, and the color is vector 4 with the result. There it is. Result is a float, but if we multiply it by a vector, color will get the vector. And alpha value 1. Let's wait for it and show everything. Okay, we can see something. It's not much, but by using the smooth step function with boundary values close to each other, we can achieve a much better result. Let's modify the line function. Okay, smooth step and arguments, as I said, close to each other, 0.5, 0.49, and the third one is our absolute value. Close the bracket and wait for it. That's better. Now we'll do something similar, but in the direction perpendicular to this shape, and multiplying by a second smooth step function will give us the intersection. So we have the first one. I'll just copy that and multiply by the second one, something like this. But now it is there is no change, of course, because we have the same argument. As I said, we'll make it perpendicular, so we'll subtract uvy from uvx, and great. From this shape, we can obtain the desired vertical and horizontal lines, depending on the final trimming, like this. Let's add a second parameter to define this. So we will have parameter called float and call it dir for direction and use it here. So let's add another smooth step. I think we can start with that and enter and change the parameters to use the direction, and the boundaries would be this time 0.1 and 0.09. Okay, select this and call it there. And of course, it's necessary to change the call from the fragment function so that the number of parameters matches the new signature. For the vertical line, we'll use the absolute value of uvx. Abs uvx, and great. This is perfect, and if I change it to uvy, we'll get the horizontal line. Excellent. We have the basic shapes already, and now we just need to arrange them correctly according to the current values of hours, minutes, and seconds. But before we get to that, let's add two new functions to make this arrangement easier. I'll call them vline for vertical line and hline for horizontal line. Let's do it here. Float vline with the parameter uv, and it would be simply return the value of line uv, and for the vertical line we need absolute value uvx. Okay, and now for the second one, let's just copy paste, rename, and make it uvy. Okay, great. What's next? We'll create a number from these building blocks. We'll arrange them in the correct position and activate them based on which lines should be active for a specific number. The number 8 has the most lines, in fact all of them, so we'll use it to show how we label the individual segments with indices. You can see it right now. So let's create a function called digit that takes as parameters the usual UV coordinates of the pixel and the number we want to display. Inside the function, we'll define conditions based on which lines are present in the current number. For example, segment 0, the top horizontal line, appears everywhere except for the numbers 1 and 4, so we'll display it for all other numbers. I'll follow a similar approach for the other cases. I will also change the scale, otherwise the number wouldn't fit on the screen. So let's do it. Here, move it. Okay, float digit with the parameters vector2 UV coordinates and integer n, which represents the number we want to display. Let's start. Float result starts at 0. And as I said, I want to change the scale, so UV would be multiplied by 3. And to get rid of this error, let's just add return result, and now we will build it. So first, for the top horizontal line, as I said, if n isn't 1 and n isn't 4, which means the line should be displayed. So let's add it to the result. Result increased by h line horizontal, applied on UV coordinates, UV. And now I want to subtract something because we'll be moving the horizontal line from the center to the top. So I'll subtract vector2, 0, 0 and -1. Okay, this is the top one, and let's add a comment. It's 0, index 0 of the structure. Now we'll do the same for others. I think I'll just copy and paste the code and skip the slow typing, so we won't waste too much time. Okay, this is the final function. I already copied here. You can see how I handle the indices 0, 1, 2, 3, 4, 5, and 6. Of course, I will add the whole shader code to my Patreon, or maybe even to godotshaders.com, so it would be easy to download. Very well, let's test the result with, let's say, number 6. I will modify the fragment function to display this number. Where is it? Here. So the result would be not line, but this time we'll use the digit function, digit with UV coordinates and number 6. Wait for it, and here we go. Everything looks fine. But before we display the entire time, we need to add colons between the hours, minutes, and seconds. This will be simple, and we'll do it similarly to how we shaped the lines. We want a square, so absolute values of the x and y coordinates will suffice, like this. So we have function digit. Now we'll add the square function, float square, again with parameter vector2 UV, and again we'll return a multiplication of two smooth steps to create a square shape. It would be smooth step of 0.05, 0.04, and absolute value of UVX multiplied by the second smooth step. I will copy and paste it here. All right, and this is the same, but for the y coordinate. What did I do? Sorry. For the y coordinate of the UV. Okay, and we'll go ahead and add a colon function where we'll combine two squares to form it. Float colon, again vector2 UV, and let's return two squares. So square 1 with parameters UV, and now we want to shift it again, so minus vector2 0 and 0.13. All these numbers are just results of my experiments, so don't look for anything special in there. You can of course change them if you want the column to have another shape or another size. Okay, the second one is vector, and we have a negative 0.13 here. Okay, we are almost there. All that's left is to put everything together in a function we'll call clock. But first, we'll need uniform parameters to pass the time data into the shader. Let's add them here. Uniform int hour with a hint range, and let's put the initial value to 0, and the hint range for hours should be from 0 to 23, of course. Now let's do minutes. Uniform int minute, again with a hint range and initial value 0, and this time we need the range from 1 to 59, of course, and the same for the seconds. I think we can just copy paste and rename second. Good. And now the mentioned clock function, which we'll insert after the colon function, which is here. It will include everything we've prepared so far. So float clock with parameter vector to uv. And again, we need some result, and we'll use it as an accumulator. 0 and return the result. And now to compose that. So first, the first digit of the hour result would be increased by the digit function on UV coordinates, and we need to shift again, this time negative 155 and 0, as we are shifting horizontally. And the value, the first digit will be represented by the hour value divided by 10. Okay, and now the second one. Let's copy paste and change this to 1. And this time we need modulo for the remainder after dividing by 10. Okay, and the first column follows, increased by column of UV coordinates minus vec2 and negative 0.65 and 0, and that's it. Yes, just colon. I think I will again make a copy paste of the code for minutes and seconds, which would be much faster. Let me do that. And here it is, hours, column, minutes, column, seconds, and result. And of course, we need to use the clock function in the fragment function. So instead of digit, we will simply use clock and get rid of this 6 on the UV. Wait for it. Okay, it looks like we need to adjust the scale so that the result fits entirely on the screen. I'll add one final uniform parameter called zoom. Uniform float zoom with a hint range, and the initial value I'll set to 3, and it would be from 1 to, let's say, 10. That's fine. Okay, and we need to use it in the fragment function right here. Yeah, UV is multiplied by zoom. Wait for it. Perfect. Now we can adjust the values of hours, minutes, and seconds in the inspector to verify that all the digits display as expected. Let me find it. Here it is, shader parameters. So let's change hours. That's too quick. Hours, minutes, seconds, everything works fine. Great. The last thing remaining, let me just reset. The last thing remaining is how to use the actual time. Some GLSL implementations allow access to the internal variable date, but in Godot, such functionality isn't available. Furthermore, we'd like to keep the option to set any time we want, depending on what our game requires. We'll solve this easily by adding a script to the root node of our scene. I'll do it here, so right click or simply click in this icon. Let's call it digital GD, sure, create. Now it opens and let's implement it. We won't need the ready function. I'll get rid of it, and instead we need the link to the color rect. So let's drag it there, click the Control key and release the mouse to create the onReady declaration. And now the function process. So first we need to obtain the time value, which will simply do it like this, var dict, because it is from the dictionary, and in fact the function contains the word dict as well. It's from the time class, get datetime, I think it's datetime dict from system. Where is it? This one. Great. And now we need to send it to the shader. So colorrect get material and set shader parameter, and the parameter for the hours is hour, I think, and we simply take dict hour from the dict. Okay, this is the hour, and now the same for minutes and seconds. Copy, minute, dict minute, and second, and dict second. That's it. When we run our scene, the shader will display the exact time and change it every second, just as we would expect from digital clock. Let's do it. And here we go. Yeah, this is the current time, the time I am recording this video. And I guess it works. Perfect. Thank you for watching. I think I'll use this shader in a new game I just started working on, where displaying digital clocks will be very useful in several places. If this shader is helpful to you as well, that would make me even happier. For now, take care, best luck with your projects, and I'll see you in the next video.